Okay folks, I'm going to try to do this answer key as quickly as possible and then post it for you. So here we go. It says find the exact value of the expression and then log base 2 of 3.2 plus log base 2 of 10. As soon as you see the plus and the logs are the same base, you're thinking I can combine them and just multiply these two. So that becomes log base 2 of 32 is equal to something. Let's call that x. And then we can just use our arrow method, bring that over there, and it's 32 to the 32 equals 2 to the x. Well, 32 is a power of 2, so that gets you to 2 to the 5th equals 32 equals 2 to the x, so just x equals 5. Okay, so it's a straightforward application of the laws of logarithms. Here we've got two functions. We've got f, we've got g. This is all about combining functions. F of g of x just means we take g of x and we substitute it in for x in the f of x. So this just becomes 2 times 1 over x squared minus 4. So that just equals 2 over x squared minus 4. There's nothing that you can do beyond that. G of f of x is then the reverse. So we take f of x right here, 2x, and we substitute that in there. So that becomes 1 over, and then in place of x being squared we put 2x and then minus 4. Well, that equals 1 over 4x squared minus 4. That equals 1 over 4 times x minus 1 times x plus 1. That's just, I've factored it out. That becomes 4 times x squared minus 1. Alright, so I don't know if you need it in factored form, but you can take the 4 out from each of these and then factor it if you want. Next is the domain for part A. What are the allowed values to put in right here? So if I'm going to put in any x value, I have no problem as long as it's not x plus 2 x minus 2 giving me a 0, because again I factor that. That's the difference of two squares. So I would say the domain is that x is all real numbers. I just abbreviate it like that, but x cannot be 2 or negative 2. Okay. The domain for part B then, having already factored this, you can see that it's very similar. X is going to be all real numbers, but in this case, pause the camera if you want and think about it. X cannot be 1 or negative 1. Each case I plug in, I'll get 0 in the denominator, and you can't have that. Alright? Sorry if the camera chopped off that a little bit, but again, can't have 1 in there or negative 1. Okay, suppose I'm given the function for this last part, that there's some function f of x, and now it's really all about the transformations. This one is going to be a translation. That's different than transformation. Translate is like a glide or a slide. Translate. And that's going to go 2 to the right. 2 units right. Because again, it's when is this going to be 0? And that's when x equals 2. So it's going to move it 2 to the right. This is going to translate 2 units up in the y direction. This is going to stretch by factor of 2. This is going to reflect it. And that's every positive x will now be the same as a negative x. Every negative x will be the same as a positive x. So instead of going out positive 3, it'll be behaving like it's at negative 3. So it reflects over the y-axis. Okay, and this last one then reflects it over the x-axis. Okay, pretty straightforward. Next page. Use the transformations to sketch the graph of this function. Again, it's similar to the last problem, but there we got a combination. the function, the parent function, f of x is equal to 2 to the x. That's going to be one of those exponentials that hugs this and hits that belly button point at 0, 1. Now what's happening here is that x minus 4, it's difficult to see in the film, but on your test you'll see it's x minus 4 is the exponent up there. That's going to move it 4 units to the right. So instead of that being at this point here, it's going to be over 4 and up 1. Okay, so it's hard to see these, but that's going to be 4 and up 1 right there. It still hugs this. Well, actually, no, be careful. It takes this asymptote and moves this down 1. So now it's at some point down here that it's hugging it, and so it moves it, the whole thing down. So this point, 4, 1 now becomes 4, 0, and that's what it's going to do, and then it's going to go up like that. Okay, so moves it over to the right 4 and down 1, and that point right there is at 4, 0. Be sure to label at least 2 points in your final graph. An easy one is also then when you plug in 1 for x. 1 for x plugged in is, well, actually plug in something so that you get 2 to the first. So plug in 5. 5 for x gives you 2 to the first power, that's 2. 2 minus 1 is 1. So that next point right there is going to be 5, 1. That's that point right there. And it's not very clear. That's that point right there, 4, 0. All right. Find the values of c and a for the exponential function y equals c a of x. So I plug in 0 for x, and that becomes 1, and I get 2. So I know that c then is equal to 2. I also know that when I plug in 2, so I've got 2/9 coming out, so I'll say 2/9 then is going to be equal to 2, because I know that c is 2, times, I don't know what a is, all right, but I know that when I plug in x is 2/9, when I plug in 2 up there for x, I get 2/9 coming out. So now I just need to solve this. If I divide both sides by 2, I get 1/9 is equal to a squared. Well, that must mean that a is equal to 1/3. All right, so I can find the value of c and the value of a, and so my function then would be that f of x would be equal to 2 times 1/3 to the x power. That will work. Okay, I'm back with properly drawn function here. It says, looking at the graph, it says, is f of x a function? Well, you just ask, does it pass the vertical line test? And yes, it seems to, so that would be a yes. And then, is it 1-to-1? That's the whole horizontal line test, and no, it is not. So that would be a big no. And is it an even or an odd or a neither function? Well, even functions are ones that are symmetrical about the y-axis. Okay. Odd functions are ones that are symmetrical about the origin, so think cubic. Okay. And this appears to be neither then, so I'll circle that. And then it says finally, state the values of x that will give you -2. So if I draw a horizontal line here at -2, it's pretty clear that when x is equal to 0, f of 0 then is equal to -2. But also one right here, and looking at it, looks like about 1/2. So when x equals 1/2, okay, then f of 1/2 also equals -2. All right, so that's a little bit by inspection. That's how you do that. Then on to the last part of the non-calculator page. Again, just do we know what it means to combine functions? F of g of 4, let's see, g is the red function, so when I go to 4, 1, 2, 3, 4, and go up to the red function, I'm here at this point 4, 4. So then you ask yourself, well, what's f of 4? What's f when I'm at 4? And I think it's at 5. My drawing might be off, but I think when I get to 4 here, I'm at 5 right there. So we would say that f of g of 4 is 5. All right? Doing the same thing now, you can pause and try it if you didn't understand before, but f of 1, That's my blue function. So when I'm at 1, I'm up here at 2, so that's 1 comma 2. So I then want to know what is g of 2, because f of 1 is 2, so g of 2 then is when I'm at 2, and that's at 0. So that is the way I figure that one. It's 0. G of 0, so when I'm at 0, I'm all the way up here at 4. So then this is like saying, well, what's g of 4? And if I go out to 4, I'm up at 4 as well. So g of 4 is 4. It's always that two-step process. Okay, well, the inverse of f at 2. So it's like saying, well, what x value gives me 2? All right, that's the way you have to think about it. It's not f of 2, it's the inverse is what x value will give me 2. And I already know that when x is 1, I get 2 coming out. So then I will say that that is going to be 1. All right, 1 will give me 2 coming out. All right.